All right, so you made it to method 2. And honestly, this method is probably the one you will use 80% of the time. And you will see it most throughout like high school and college, again, if you take math classes in college. Just because, again, factoring is very popular with trinomials. What a trinomial is, again, if you look at like the problem I provided here, 2a and 2b, again, it means there's 3 terms. So a binomial meant there's 2 terms. Again, a trinomial, there are 3 terms. So there's no special name for this method. Again, that's why for method 2, I just wrote factoring trinomials. Again, there's a few different ways people say it. So again, it's called like an AC method, or again, factoring trinomials, or factoring polynomials with 3 terms. Again, it's all going to be the same thing. Okay, so let me just run through problem 2a. Again, you can pause it at any time if I go too fast, too slow, and then you can go ahead and try 2b on your own. So there are 2 key factors for this method. Again, you're going to want to find, and this is the key here, you want to find 2 numbers that multiply to get this last number here. Again, this is what we want to multiply to. And you want to find the same 2 numbers that have to add to this middle term of 7. So again, you have to find 2 special numbers or 2 special factors that are going to multiply to 6 and are going to add to 7. Okay, and again, sorry I forgot to say in the beginning, just to note here, pay attention, the polynomial is set equal to 0. So again, we can't use anything with the GCF because again, I don't have a number out in front here, it's just a 1. So there is no GCF between 1, 7, and 6. Again, so we can't use the GCF method, there is no GCF to pull out. Okay, so again, it wasn't the GCF method, I see it set equal to 0, so again, I'm learning this new method here. And again, key is to add to the number in the middle, so add to 7 and multiply to the number at the end, 6. Okay, so the way we're going to do this, there's so many different ways you can do it, and you can walk across the hall and ask Miss Sordo or Miss Warska or any of the math teachers in the freshman center or any high school you walk into, and they can show you a different way to represent your factors. Again, I think a table is a very clean way to see all of your possible factors, and I'm sure a lot of you will like to use a table. But again, if you want to see a different way, you can always ask me and I can help you find a different way. Okay, but again, I want to organize a table so I can find what's going to multiply to be a positive 6, and I want something that's going to add to 7. Again, those are the 2 magic numbers we're looking for. 2 numbers that multiply to 6 and add to 7. Okay, and I'm going to start listing numbers that multiply to 6. So 1 times 6, 2 times 3. And again, remember, you can do like -1 times -6, -2 times -3. So again, all of these are going to multiply to 6. 1 times 6 is 6, 2 times 3 is 6, -1 times -6 is 6, -2 times -3 is 6. Again, all of those multiply to get me a 6. Okay, now on this side, again, I'm going to add them and see which pair adds to 7. So 1 times 6, now I'm just going to add them instead. 1 plus 6. Would you look at that? The very first one, again, we ended up getting our answer, but we'll just keep going. So 2 plus 3 gets us to 5. Again, that's not 7. -1 plus -6 gets you -7. We don't want that. -2 plus -3 is -5. We don't want that. So luckily in this case, again, the way I just did it, you ended up with finding the right pair right in the beginning. Okay, so this is going to be the magic pair here, the number 1 and the number 6, because it multiplies to 6 and 1 plus 6 will add to 7. Okay, and this is the way we factor it out. So you're going to start with 2 sets of parentheses. Okay, you're going to set them equal to 0. Again, just like our problem was equal to 0, you start with 2 sets of parentheses. Okay, our very first term was x squared. If we want to split x squared evenly, in our first set of parentheses we have an x, and the second set of parentheses we have another x. So again, x times x will get us back to this x squared here. Remember, factoring is going backwards. Again, you're breaking things apart, you're dividing things. So again, people have a hard time like understanding the concept that we're starting with some kind of polynomial and we're pretty much breaking it down. You're making the question look harder than it is. Again, you're breaking it down into its factors. So sometimes, again, we're stuck in this mindset that I start with some hard question and I want an easy answer like x equals 10. Again, get out of that mindset. We're doing some like completely different concept here of factoring. Your answer is going to look probably more complicated than what you started with. Okay, so I had x and x. And again, this is how I'm going to show these two factors. I have a positive 1 and a positive 6. So in one set of parentheses, you have a positive 1. In the other set of parentheses, you're going to have a positive 6. So this is what your two factors look like. You have x plus 1 and x plus 6. And again, you put them separately in two sets of parentheses there. And that is the factoring method for trinomials. Again, we're going to use this table, find some magic number, again, that multiplies to the last number, so multiplies to the 6 in this example, and has to add to the middle number. Okay, at this point, again, please pause the video for a few seconds. I'm going to like super speed run through this example so you can check to make sure you did it correctly, but take about 5 or 10 minutes and see if you can do 2b on your own. Do it exactly how I did problem 2a. See if you can follow this method and try it out on your own. Again, I'm just going to pause for a second. I will put up the answer so you can check. All right, so you probably unpaused by now. Again, I'm just going to like super speed run through it. Again, I'm not going to go through all the details, but I know I'm going to look for a number that multiplies to 12. And I need a number that adds to the middle, so adds to -7. And again, I know I'm going to have a negative somewhere because I want to add to -7. So let's just start randomly listing the factors of 12. Again, you can do them in any order you want. It doesn't matter. We're just going to have to find the one that works. So 1 times 12 gets me to 12. 3 times 4 gets me to 12. -3 times -4 gets me to 12. 6 times 2 gets me to 12. -6 times -2 gets me to 12. Again, all of those multiply to 12. Okay, let me now add them to see which one is going to add to -7. 1 plus 12, 13. 3 plus 4, 7. -3 plus -4, -7. Again, I see this is going to be the magic one here that we want. 6 times 2, again, I'm adding now. 6 plus 2 is 8. And -6 plus -2 is -8. So again, I see the pair that worked here is going to be x minus 3 and x minus 4. Okay, and again, that's your full factored form. X minus 3 times x minus 4 equals 0. That is going to be the factored form of your polynomial we started with. Okay, again, once you're comfortable with these two, you can go ahead and move on to method 3.